Today, we're going to pull back the curtain on this hidden engine that powers, well, just about everything, from the car in your driveway to the weather itself. You're about to see this incredible link between our own complex machines and the natural world, and it's all driven by one single fundamental force.
Okay, so let me just start with a question that I admit sounds a little bit like a riddle. What on earth could a loud, grimy car engine possibly have in common with a gentle, cool ocean breeze? I mean, they feel like they're from different universes, right? But stick with me because you're about to find out they are secretly running on the exact same operating system.
So, to crack this mystery, let's start with something we all pretty much know, the internal combustion engine. Yeah, we know it makes a car go, but how it turns a tiny drop of fuel into actual motion, that's where our first big clue is hiding.
Right. So inside most cars, you've got this thing called a four-stroke engine, and it's really like a beautifully timed dance. First up is the intake stroke, where the piston drops down and sucks in this fine mist of fuel and air. Then, compression. The piston shoots right back up, squeezing that mixture into a super tiny space. And then you get the magic moment, the power stroke. A single spark creates this tiny, controlled explosion. And finally, exhaust, where the piston pushes all the used-up gas out and the whole thing starts all over again.
But see, the real action, the part where all the power comes from, is in that power stroke. And as this quote from Energy Education points out, the secret ingredient isn't just the bang itself. It's the incredible heat that the explosion creates. This heat makes the pressure inside that cylinder skyrocket, and it's that massive pressure that just violently shoves the piston down. That's the force that actually turns the car's wheels.
So here's the bottom line. Let's forget all the gears and shafts for just a second. The engine's real secret is just a basic rule of physics. When you add heat to a gas, you create a ton of pressure, and you can use that pressure to create powerful motion. Remember that. Heat creates pressure, and pressure creates motion. Now let's figure out why. We just established that heat is the real hero inside our engine. But what even is heat? What is temperature really? To get how it builds up so much pressure, we need to zoom in. I mean, way in, down to the microscopic level.
You know, at its heart, temperature is really just a measure of movement. Everything is made of these tiny atoms and molecules, and they are never still. They're constantly jiggling and vibrating and bumping into each other. Temperature is basically just the average speed of all that microscopic chaos.
So, with that in mind, what do you think happens when we add more energy, in the form of heat, to something?
Well, those little particles soak up that energy, and they just start moving faster and faster. They vibrate like crazy and slam into their neighbors with way more force. The whole system just gets a lot more agitated, a lot more energetic.
And all of that frantic, super fast motion, that's what creates more pressure. If you've got them in a closed space, like our engine cylinder, those hyperactive little gas particles are just hammering the walls and the piston way harder and way more often. And there it is, the perfect link. More heat means more particle motion, which means more pressure. Okay, so we've cracked the engine's secret. But let's ask a bigger question. Where else can we see this exact same principle? Heat creating pressure differences that lead to motion. Let's zoom out. We're going from the tiny space inside a piston to the entire planet. Let's take a look at our coastlines. The engine that drives the weather along our coasts is something called differential heating, and the key idea is really simple. Land and water heat up from the sun at totally different speeds. Land heats up super fast. Just think about how hot sand gets at the beach, right? But water can absorb a ton of heat without its temperature changing very much. And that one simple difference is what gets the whole engine started. And here's where it connects back to our car engine. A difference in temperature creates a difference in pressure. The air sitting over that hot land gets heated up, its particles start zipping around faster, and it starts to rise. That creates an area of lower pressure. Meanwhile, the air over the cooler sea is denser and heavier, creating higher pressure. And nature, well, it doesn't like an imbalance, so?
And this process creates this really predictable daily cycle. So during the day, the land gets hot, it creates that low-pressure zone, and it starts pulling in the cooler, high-pressure air from over the ocean. That's what we call a sea breeze. But then at night, the whole thing flips. Land loses its heat way faster than the water does. So now the land has the high pressure, and the wind starts blowing out towards the lower pressure zone over the sea. We call that a land breeze. It's this huge natural engine just cycling back and forth every single day.
So now we have our two examples on the table. the man-made engine and the completely natural breeze. I mean, they seem like they're worlds apart, but we've seen this secret connection between them. Let's put it all together.
This is it. This is the one principle that unites them. In an engine, you're using chemical energy to rapidly heat a small bit of gas. That creates a pocket of crazy high pressure that physically shoves a piston. On a coastline, you're using solar energy to slowly heat a huge landmass. That creates a vast area of low pressure that pulls air in from the ocean. You see? The scale is totally different, but the physics, it's identical.
And that is our big takeaway today. It honestly doesn't matter if you're talking about a tiny piston inside a metal block or a massive planetary weather system. The fundamental rule is the same. When you create a difference in temperature, you create a difference in pressure, and that difference will always create motion. It's one of the most powerful engines in the entire universe.
So, this hidden engine, it really is everywhere. You know, it's what drives ocean currents, it's what lifts a hot air balloon, it even stirs the water in a pot on your stove. The next time you start your car or feel that cool breeze on your face, you'll know about the powerful and visible force that's really at work. So my question for you is this. Now that you know what to look for, where else in your world can you see this principle hiding in plain